So the first example problem, this is the constructing the VT and AT graph. Kung mapansinin nyo dire, ang given is ST. ST ang given. And this is the, it describes the motion of the bicycle itself. Erratic siya because kung i-zoom in ako, during the time interval na 0 to 10, 0 to 10 na to, ang iyahang function or ang pag-describe sa iyang motion is illustrated with s is equal to t squared. Pero pag abot sa 10 to 30 seconds na time interval, it is described with the function na s is equal to 20t minus 100. So mo na erratic motion ang i-consider dire. Kay every time interval, nagalahi na function ang i-consider. So a bicycle moves along a straight road such that its position is described by the graph shown in the figure below. So this is your graph, and ang klaseng graph ani is ST. This is ST, so makonstruct na to una si VT, then afterwards si AT. And what we need to construct, VT and AT graphs for the time interval 0 to 30 seconds. So here sa kilid, these are the, what you call this? The graph for the VT and AT graph. So let us construct the VT and AT graph. So just a solution. Diba, as I mentioned kanina, if ever ST ang given sa problem, ang una niyo ma-construct kay si VT using this kinematic equation, V is equal to ds over dt. And afterwards, kung ma-construct nimo si VT, ma-construct na pod nimo ang corresponding AT graph using this kinematic equation na A is equal to dV over dt. And ang imong gamiton for you to construct the VT and AT graph from the given ST graph is using derivative. So una ang atong ma-construct na graph is the VT graph. So we will construct first the VT graph. VT graph. Do you follow everyone? Naka-follow bang everyone for this problem? So for this one, sa VT graph, since duha man siya time interval, 0, 10, then 10, 30, lahi ang ato ang solution each of the time interval. So first one is the first interval na 0 to 10 seconds. So that would be 0 to 10 seconds. So during the time interval na 0 to 10 seconds, ang motion niya is described with the function na s is equal to e squared. So from this equation, kailangan nato i-convert this equation into a function that describes the velocity. So using the kinematic equation na v is equal to ds over dt. So we substitute here the S, that is t squared. So V is equal to d over dt. Then you substitute the equivalent of S. So nga no derivative, kay tungod, kung makita ninyo sa akong solution, ang atong ma-perform ani is derivative since wala na may d, v naman na variable ang naa, and it is a derivative of a function which is a t squared with respect to the time. So therefore, ang atong ma-apply ani is diretso na derivative. So for the velocity, ang equation sa atong velocity for this time interval is 2t. So from 0 to 10 seconds, ang velocity is equal to 2t or 2 times the time. So mo na to ang i-graph later on, afterwards. The same thing, during the time interval na 10 seconds to 30 seconds, S is equal to 20t minus 100. So the same na nga itong gibuhat dire kanina. We use again with the same kinematic equation. Then the S na to, substitute na to ang equivalent sa S, that is 20t minus 100. O pila matong velocity? Based sa to ang koan. Pila tong velocity ana? Pag derivative na to. 20. Kung sa'y pasabot kong 20? Constant. So kung magkuan ta, kung mag-construct na ta sa tong 80, unsa may value sa to ang 8 ang acceleration kung ang velocity is constant?
Constant.
Unsa man ang value sa acceleration if the velocity is constant? 9.81?
0, sir.
That would be 0. Eh, di ba kung mag-derivative tag constant, basic rule, when you derivative a constant, that is equal to 0. So later, kung mag-construct na tag 80 graph, using kaning gikan sa equation sa velocity, ang v is equal to 20, which is the constant, kay ang atong ma-solve later on sa acceleration would be equal to 0. Okay? So i-construct nato ni siya. We will construct this one. So atong VT graph, oops. So atong VT graph ani, just a continuation. So your VT graph, your vertical axis represents the velocity. Horizontal axis represents the time. And then natay origin here. At first, for the time interval na 0 to 10, it describes with the function na v is equal to 2t. So it is a linear equation. It is a line. And kung mag-graph tag line, depende man gud kung unsa ang iyang slope, kung upward ba siya or pa downward. That's why it's very convenient to use a online graphing calculator. Ang sauna tong nang handle ko og ES17 before during face-to-face rather, kay manual lang among pagbuhat ani, pero since online man ta and we need to use some available resources, so we can use some um, graphing calculator na pwede nasa online, or if you're using a phone na siya app ana. Okay? Kahit ang actual calculator, kakuan mo ng graphing calculator, di ba? Scientific calculator man to gigamit karon. Kita na mo anang graphing calculator na ma-graph niya ang koan, mag-graph niya ang isa ka function. Actually, mahal, wala pa. Kita ko to before to college man nato to. I think sa amo ang college sa una kay nami graphing calculator. Not sure sa CGS kung na may graphing calculator. Na-remember ganit na ko na nakoy isa ka classmate ata before sa college na iyang calculator is actually a graphing calculator. Okay? So pwede nimo siya magamit to graph the function, makita nimo, magamit man gud nimo siya kung for example gusto nimo may bawaan unsay itsura sa unsay graph sa imuhang equation. Okay? Usually disod na siya kung quadratic or cubic. So kana needed jud nimo o graphing calculator. Kaning sa to pwede na nato gamiton mga available na graphing calculator online or kanang mga app. So later sa second example, I will show you the graphing calculator that I'm talking about. Sa first time interval, that is 0 to 10. That is V is equal to 2t. And the second time interval is 10 to 30 seconds. So it has motion described with a constant velocity of 20 meters per second. So pag graph ani, ang V is equal to 2t, it is actually a linear. So pasaka na siya. So until 10 seconds lang na ang atong koan. So this is V is equal to 2t. So di ba kung mag-graph na to ang V is equal to 2t nga niyang itsura, then i-connect na to ang next na motion that is V is equal to 20. So since it is constant, it is actually horizontal. So horizontal line ang atong koan. So this is V is equal to 20, then that is until the time na 30 seconds. Sometimes we enclose it with a dashed line. And atong na-form here sa atong graph is the VT graph nato. So makita nimo na pagtanaw, ang purpose magud ani, pagtanaw pa lang nimo sa graph, increasing siya during the time interval na 0 to 10, pero pag abot sa 10 to 30 is constant. Okay? So meaning constant, dili siya increasing or decreasing ang iyang velocity. Throughout the time interval na 10 to 30, it is 20. So that is the graph for your VT. So afterwards, kung mag-construct nimo si VT graph, change kong screen. Here. So next is when you construct the AT graph, since na-construct nimo si VT, you can construct the AT graph using this kinematic equation. A is equal to dv over dt. So the same lang atong gibuhat kanina. So ang first time interval, 0 to 10 seconds. And ang function that describes the velocity during this time interval was v is equal to 2t. Then we can identify its acceleration using this kinematic equation. So that would be A is equal to d over dt. Then the v will be substitute with 2. So unsa man nato ang acceleration? 2t di. So pila man nato ang acceleration ana? What is the value of our acceleration? Derivative sa 2t with respect to time. That will be 2. So it has a constant acceleration, so 2 meters per second squared. The same thing during the time interval na 10 seconds to 30 seconds, that was represented with a function v is equal to 20, which is a constant. So kahit dili nato i-substitute, kabalo naman jud ta na ang acceleration ana would be equal to 0. So pag substitute nato, ang derivative anding sa 20 with respect to time, since it is a constant, will be equal to 0. So pag construct kay AT graph here, the same na itong gibuhat sa VT graph. Vertical is the acceleration and horizontal is the time. Again, this is the origin. During the time interval na 0 to 10, ang iyang acceleration is 2. So 1, 2. So since it is a constant acceleration, horizontal line na siya, until the 10, until the time na 10 seconds. Then afterwards, pag abot sa 10 to 30 seconds, ang imong acceleration is 0. So it lies within the horizontal axis. So starting from 0, change lang na kong color. Until 30, say dirang 30. So it is represented with a red color. So that is T. So dira kotob sa 30. So therefore, this one is A is equal to 2. And for 10 to 30 na interval, that is A is equal to 0. So kani pag connect, you just only connect that with a dash line. And that would be your graph for your AT graph. And if you notice, constant ang iyang acceleration throughout the time interval starting from 0 to 30. Especially that pag abot sa koan, 10 to 30, it has zero acceleration. So this is how we graph for the VT and AT, especially the given problem. Sa given problem, ang gihatag na graph is ST. So kung ST ang given, just a recap, you can construct the VT using this kinematic equation. Then, after ma-construct nimo si VT, ma-construct nimo si AT using this kinematic equation. Then, ang gamito nimo would be or by applying derivative. Okay? So, do you have any question on this example?